Hello all, I Dr. Sarika Panwar welcome you all for the video lectures of machine learning. Today's topic of discussion is decision tree. In earlier lecture we have seen that what is the difference between supervised machine learning and unsupervised machine learning. We know that in supervised machine learning the labels are used, and in unsupervised machine learning unlabeled data is used. Supervised machine learning algorithms are nothing but the classification and regression algorithm. So decision tree is the most powerful and popular tool for classification and prediction. Decision tree can be used for classification as well as regression. It is a flowchart. We know the tree structure of data. Data structures tree we know. So similarly, decision tree is also algorithm which is having a flowchart like structure. It is having a flowchart like tree structure, wherein each internal node denotes a taste on an attribute, and each branch represents an outcome of the taste, and each leaf node or terminal node holds a class label. Now, if we consider the case of, we will try to understand the decision tree with the help of one database. Now, see here, this is a problem wherein there are four dependent variables. So, outlook, temperature, humidity, and wind. These four are the dependent variables which we can call as an attributes or a features. So there are four input features in this data set and one output variable, that is played football or played tennis, which is nothing but the independent variable. So for this problem, we will try to understand how to draw what is the decision tree. So here, see, there are four attributes. Those are the dependent variable on which the played football, that is output, is uh, dependent. So these four are called as the dependent variable. So these attributes or dependent variables has got some values like outlook has got the values of sunny, overcast, and rain. Outlook variable has got these four values: sunny, overcast, and rain. Humidity has got the two values, high and normal. Wind has got two values, strong and weak. And temperature has got three values, that is hot, mild, and cool. And one target concept, that is output, is there. So whether a player will play a tennis or football, or he will not play a tennis or football. Okay, so here these are nothing but the dependent variable attributes, and every attribute has got some values associated with it. So to classify a particular input sample into output, we can use the decision tree. So this will be the decision tree for playing a tennis database. So here this particular node is nothing but the parent node. So out of these various attributes, we have seen that there are four attributes in this data set. Okay, so out of these four input attributes, we can start from any attribute. Okay, so the attribute which we start from, that is nothing but the parent node. So here, if we are starting from the outlook attribute, this is nothing but the parent node, and at each here we will perform a test, and on this test, based on the test, it can take any value out of the sunny, overcast, and rain. So this is the parent node. Okay, and once we decide on the parent node, based on this test value, it can take any path. So what will be the outcome of this test? Sunny, overcast, these are the outcome of the test. And what is the class label? Output, that is whether a player will play a tennis or football or not, that these are nothing but the class label. So these leaves of this tree are nothing but the class label that we need to understand, and these nodes are nothing but the attribute. So every node in the decision tree is nothing but our attribute, or we can call it as a feature. And these leaves yes, no. These lists are nothing but our output classes. Okay, that is nothing but the class label. So these are the basic things we need to understand. So what is our task? If we have to do that classification problem, we have to solve some problem by using the classification algorithm, then we can use the decision tree. So decision tree is nothing but one of the classification or regression algorithm which can be used for classification task or the prediction task in regression problem. So now, see what if the data set is given to us, then we can use that data set to uh, design a decision tree. Okay, so decision tree designing is the major task. Now, see, as we have seen earlier, that in any function which we try to come up in machine learning, so only one function cannot be there. There can be more than one function which can come up after the learning process. The we will select the optimal function. We can select the optimal function like in decision tree. When when we start learning the decision tree in Python or in Python or MATLAB, then we can come up with various decision tree. There cannot be only one decision tree which we can say that this is the best one, and now this decision tree can be used for further classification in real life. This cannot be the case. See, there can be more than one decision trees. We have to select the optimal one wherein we can get the minimum error and maximum accuracy. So first we will discuss the important terms in a decision tree, and then we will understand the decision tree by solving one numerical example. So first important term is entropy. Entropy in information theory, also we have studied this term entropy. It is the measure of randomness in the information which is being processed. Okay, and if the entropy is higher, the harder it is drawn to any conclusion from that information because there is randomness in that data. That's why we cannot draw any conclusion from that data. So if entropy is higher, then randomness is more, and it will be difficult for us to draw any conclusion. So basic formula of entropy, it is based on the probability of occurrence of that particular information. Okay, so if probability is more, then depending on that, the entropy we can get. Okay, so h of x is equal to negative of summation from I is equal to 1 to n, probability of xi log to the base 2, that is the binary log probability of xi. Okay, so this is the formula for entropy, and based on the entropy we can find the information gain also. So information gain, it is the amount of information gain about the random variable or signal from observing another random variable, and it can be considered as the difference between the entropy of the parent node and weighted uh, average entropy of the child node. It is calculated for the split by subtracting the weighted entropies of each branch from the original entropy. Information gain, it is calculated over the whole sample space. Sample space means whole data sample. Um, so information gain is equal to S comma A. A is a particular attribute, like in this example which we have seen recently, in that there are four attributes. So for any attribute we can find the information gain, that is equal to the entropy of the whole data set minus summation over values of the particular attribute. So if we are considering four attributes, so summation of all four attributes, and for that particular values of that attribute. So that is the formula of the information gain. So what are the issues in the decision tree? Okay, so as we have seen earlier that we can come up with more than one decision tree when we try to learn a decision tree algorithm with a particular data set. Then we may think that this particular decision tree is the best one, but in second iteration we may get the more better decision tree than the earlier one. So we can come up with more than one decision tree in a particular learning or particular iteration. So which one we can select, that is the major issue. Okay, so there are various issues in decision tree. Given some training example, what decision tree should be generated, that is the major task. And one proposal is that we need to prefer the smallest tree. We have to remember that the tree having the minimum depth will be the best decision tree. So and for that, for finding the best decision tree, smallest decision tree having the minimum depth, possible methods are to search the space of decision trees for the smallest decision tree that fits the data. So where we get the minimum error will be the base tree, where we get the minimum depth will be the base tree. And so that is the issue. So we will consider this decision tree problem for the numerical solving, and we will solve this problem step by step in our next video. If you like this video, then please subscribe my channel and like this video. Thank you all.